Good morning, students. Today we are going to discuss telescope. Now, telescopes, here we are going to discuss, one is your refracting telescope and another one is your reflecting telescope. Now, it is under the chapter ray optics and optical instrument. Now, basically, telescope is used to see an object which is very far, maybe a star, maybe a planet. Now for this, as we have to see a distant object, that's why the objective is of larger aperture compared to the eyepiece. But in case of microscope, things are reversed. As we have to see the small object, that's why the objective is smaller and eyepiece is larger in case of microscope. But in telescope, the objective is larger aperture than the eyepiece. Now, as the object is very far, that's why we will consider parallel ray. So, parallel rays will come and strikes on the objective, and they will suffer refraction, and after that they will intersect at a particular point, and that point gives the image, and that image acts as an object for the eyepiece, and finally we wish to get a magnified image. Now here object is at infinity, parallel rays are there. One of the ray makes an angle alpha with the principal axis, and after intersection of the reflected rays, we used to get an image AB. Now that image AB acts as an object for the eyepiece, and definitely the object, as the object is at infinity, that's why the image is formed at the focus of the objective, that is f0. Now that object definitely within the focus of the eyepiece, that's why we used to get an inverted, that's why we used to get a virtual image, erect virtual. Now as per the diagram, the object is at infinity, that's why AB is at focus of objective, that is f0 focal length, and AB is within the focus of the eyepiece, and for that arrangement we used to get an image, that's a virtual image A dash B dash. Now that image is formed at the least distance of distinction, that is V equal to D, and UE, E for eyepiece, and the image, the reflected ray makes an angle beta, and the incident ray makes an angle alpha with the principal axis. Now as per the definition of magnifying power, this is nothing but is your beta by alpha. Now beta, as it is small, that's why 10 beta by 10 alpha. So 10 beta you can consider AB by O2A, and 10 alpha you can consider AB by O1A. So on simplification, O1A by O2A. So O1A is your f0, because the object is at infinity, that's why image is formed at the focus of the objective. So O1A is your f0, and O2A, if you see, O2A is your UE. So that's why, as it is against the direction of the arrow, that's why minus UE. So magnifying power coming out to be your f0 by minus UE. Now you are going to use lens formula in eyepiece. So 1 by V minus 1 by U 1 by F. So the image is formed at the least distance of distinction, and as we have to move from O2, that's why it is against the direction of the arrow of the incident ray, that's why minus D. V is for minus D, and U is for minus UE, again U suffix E, that's why minus minus plus. So 1 by UE you will get 1 by FE plus 1 by D. So 1 by FE we take common, then it should be your FE by D plus 1. Now as you are interested in defining magnifying power, so 1 by UE you can substitute. So once we substitute, then it becomes f0 by FE minus sign 1 plus FE by D. So this is the magnifying power for an image that forms at the least distance of distinction in case of telescope. Now the length of the telescope is nothing but the gap between objective and eyepiece. So if you consider objective and eyepiece, then f0 plus UE gives you the length of the telescope for least distance of distinction. Now for normal adjustment, this is your diagram. So again the same thing happening here, but the final image is formed at the infinity. So as the image initially at infinity, it forms at the focus of the objective, and as this object AB is at the focus of the eyepiece, that's why we wish to get an image which is at in infinity. So magnifying power again, beta by alpha, so 10 beta 10 alpha, so AB by O2A and AB by O1A. So O1A by O2A, so O1A is nothing but F naught, and O2A is your FE with the negative sign as you are moving against the direction of the arrow. So F naught by minus FE. This is the magnifying power for normal adjustment in case of telescope, and the length of the telescope is nothing but is your F naught plus FE, because it is nothing but the gap between objective and eyepiece. So F naught plus FE gives you the length of the telescope. So here the image is at the same point where both the focus lies for objective as well as eyepiece, and F naught FE is nothing but the focal length. You can show it in diagram F suffix capital F suffix E if you want. Here is also you can show F suffix capital E if you want to show in the diagram. Okay. Now next one is your reflecting telescope. This is your reflecting telescope. Now this is your reflecting telescope. So here you see in the diagram, you do have primary mirror, you do have secondary mirror, and you do have parallel rays of light from a distant star. We are trying to see an heavenly object. So rays comes and strikes on the primary mirror, and it suffers reflection, and after that they enters in the eyepiece. Now secondary mirror and primary mirror is there. Now this is your reflecting type of telescope, and these two are reflecting type of telescope. Now in case of magnifying power, focal length of the concave mirror F naught divided by focal length of the eyepiece. So that is nothing but is your F naught by FE. So in exam basically reflecting type of telescope they used to ask, and you please go for the diagram. These diagrams are very important. Sometimes they used to write the magnifying power expression and the ray diagram. Okay, so please go through the diagram and practice this diagram. These diagrams are very important for your exam, and see what is happening. So as we have said, this is your image, and the object is at infinity, that's why it is at the focus of the objective F naught O, and this is within the focus of the eyepiece, so you can consider this is your FE. Then this one is within the focus of the eyepiece, that's why you used to get a magnified virtual image. Okay, now again I am trying to show it here. This point is at the focus of the objective because rays are coming parallel, that's why they intersect and image is formed at the focus of the objective. This is your objective. Now this one is at the focus of the eyepiece also, that's why we used to get an image which is at infinity. So this point is again you can consider F suffix E. Okay, this is your F suffix E also. So this is all about. Please go through this part, and this part is very important for your exam, ray diagram as well as the magnifying power. Check it out. Ray diagram and magnifying power, and this is your reflecting telescope. Sometimes it is asked, but maximum time reflecting telescope used to come in exam. So this is all about. More we will discuss next class. Thank you.